What is going on, everybody? Got another video here for you, business calculus, marginal analysis, and approximations using increments. So it's a pretty good video, a lot of word problems. If you're not in business calculus in a regular calculus class, watch it. You'll learn some more stuff with different types of word problems. All right, so let's get started. So we've got marginal cost, marginal revenue, and marginal profit. So marginal cost, if C of X is the total cost of producing X units of a commodity, then the marginal cost of producing X naught units is the derivative C prime of X naught, which approximates the additional cost C of X plus 1 minus C of X naught plus 1 minus C of X naught incurred when the level of production is increased by 1 unit from X naught to X naught plus 1. So it's the cost incurred when you increase your production level by 1 unit. Okay, and that's where the approximation using increments comes in. Notice this is when you increase it by 1 unit. But what if you want to increase it by half a unit? Okay, that's where this using increments, and that's towards the end of the video. We'll do some problems with that. And then marginal revenue and marginal profit, it's similar. It's just done with the revenue and profit function instead of the cost function. So suppose R of X is the revenue generated when X units of a particular commodity are produced, and P of X is the corresponding profit when X equal X naught units are being produced. Then the marginal revenue, X prime of X naught, it approximates the R of X naught plus 1 minus R of X naught, and the additional revenue generated by producing 1 more unit. And then marginal profit, it's the same thing. It's with the profit function. Okay, the profit of producing 1 more unit. All right, so let's go ahead and get started on some examples. It says a manufacturer estimates that when X units of a particular commodity are produced, the total cost will be this. C of X is equal to 1/8 X squared plus 3X plus $98. And furthermore, that all X units will be sold when the price is P of X. So this is your price, 1/3 times 75 minus X dollars per unit. So they want us to find the marginal cost and the marginal revenue. All right, so for part A, let's write down our cost function. So all I'm doing here is I'm writing down this function here. That's going to be 1/8, let's see, X squared plus 3X plus 98. And then let's just go ahead and write down the P of X, our price, which that's 1/3 times 75 minus X. That's your price there. Now we're going to need these values later. So for part A, they want us to find the marginal cost and the marginal revenue. All right, so for the marginal cost, that's just taking the derivative of the cost function. So that's C prime of X is equal to 1/4. That's 1/4 X plus 3. There's your marginal cost. Now we want to find the marginal revenue. Well, in order to do that, we need to know what the revenue function is. So remember, you got a little formula here that your revenue function is number of units sold times price per unit. That's your revenue function. So in this case, our revenue, change colors back. Our revenue is equal to number of units sold. Well, how many units are we selling? Well, let's see, where does it say that? When X units of a particular commodity are produced, well, X represents the number of units. So that's going to be X times the price per unit, which is 1/3 times 75. 75 minus X. And so R of X is equal to, so if I distribute, so what I'm going to do here is I'm going to distribute this 1/3 X. And so that's going to be 25X. So I'm just distributing that to each term, minus 1/3 X squared. And so the marginal revenue is equal to 25 minus 2/3 X. So there's your marginal revenue, and there's your marginal cost. All right. Now for part B. Part B says use marginal cost to estimate the cost of producing the 9th unit. Okay. So the marginal cost of producing the 9th unit, so that's going to be C prime of, now, what are we going to plug in for X? We want to know the marginal cost for producing the 9th unit. So remember, this C prime of X naught, which approximates the additional cost C of X naught plus 1 minus C of X naught incurred when the level of production is increased by 1 unit. So we want to go from 8 to 9, right? So in this case, the X naught is 8. So we're going to evaluate the cost function at 8. Okay. So that's going to be 1/4 times 8 plus 3, which is equal to, and that's going to be $5. Okay, so that's not bad. All right, so basically whenever they ask you to, if they want to know the marginal cost of producing the 9th unit or the 10th unit or the 11th unit, whatever number they give you, you're going to evaluate it at 1 less. Okay, because when you evaluate it at that 1 less, that gives you the cost of that extra unit, that 1 additional. So going from 8 to 9, and that's what they wanted to know, the 9th unit. And then part C, what is the actual cost of producing the 9th unit? Okay, so the actual cost of producing the 9th unit is going to be C of 9 minus C of 8. So if you take how much it costs to produce 9 units minus how much it costs to produce 8 units and subtract those, then that'll give you how much it cost for that 9th unit. And so now notice this is C, not C prime. So we've got to plug that into this function. Okay, into C. So that's going to be 1/8 times 9 squared plus 3 times 9 plus 98 minus 1/8 times 8 squared plus 3 times 8 plus 98. Now remember, this right here is C of 9, and this right here is C of 8. But remember, it's minus this whole thing here, this minus this whole C of 8. So that has to be in parentheses. And then when you punch all that into your calculator, you get $5.13. All right. All right, so let's look at part D. Use marginal revenue to estimate the revenue derived from the sale of the 9th unit. Okay, so that's going to be what? R prime of 8, right? So that's going to equal 25 minus 2/3 times 8. And that's going to give us $19.67 when you punch all that into your calculator. And then part E, they want to know what is the actual revenue from the sale of the 9th unit. So for this one, let me erase that. So for this one, we've got to use this function. So this is going to be R of 9 minus R of 8. That's your revenue function. So that's going to be 25 times 9 minus 1/3 times 9 squared minus, and then don't forget to put R of 8 in parentheses, 25 times 8 minus 1/3 times 8 squared. And when you punch that in, that's going to give you $19.33. And there's your answer. All right. So, it's not a bad problem. Not bad at all. All right, let's look at some more examples. It says a manufacturer of digital cameras estimates that when X hundred cameras are produced, the total profit will be P of X is equal to all this mess, $1,000, and this is in thousands of dollars. Find the marginal profit function. So that's part A. Part A, the marginal profit function. So that's going to be P prime of X is equal to, so we've got to find the derivative of this thing. So that's going to be negative 0.0105 x squared, right? The 3 comes down 3 times this, and then subtract 1, plus 0.14x plus 25. So there's your marginal profit function right there. And then for part B, what is the marginal profit when the level of production is 10, 50, and 80? So this is P prime of 10. All right. And so when you punch that into your calculator, you get 25.35. 25.35. Now, I know what you're thinking. But you told us to plug in 1 less, so why am I not plugging in 9? How come I'm not plugging in 9? Why am I plugging in the 10? Because that's what we did up here when we did the 9th unit. We plugged 8 in, right? Well, notice this problem here. Use marginal cost to estimate the cost of producing the 9th unit. But this one is just saying what is the marginal profit when the level of production is this. They're not asking for a particular unit. But what we're going to do after this, we're going to interpret these results here. And so P prime of 50, this is negative 0.0105 times 50 squared plus 0.14 times 50 plus 25. And that's going to give us 5.75. And then P prime of 80, and I'm not going to plug it in. When you plug that in, you get negative 31. Okay, you would just, instead of the 50, you would have an 80. Instead of the 10, you would have an 80. It's the same thing. All right, now that's good and everything, but what does it mean? What does this mean? Well, notice we've got P prime of 10 is 25.35, which that means that a one unit increase in production from 10 to 11. Okay, so going from the 10th unit to the 11th unit, 100, from 10 to 1100 cameras, because remember, where is it? X 100 cameras. Okay, so when we go from 1000 to 1100 cameras, increases profit by approximately $25.35 thousand. So going from 1000 to 1100 units, that's going to increase the profit by $25.35 thousand. And then here, if we go from 50 to 51, okay, that's going to increase the profit by about $5,750. Okay, and this 25.35, that's 25,350. Okay, you multiply by 3 moves. Okay, or I'm sorry. Yeah, you change it because this is thousands. So you move it 3 places to the right to get the dollar amount. And then with 80, increasing from 8000 to 8100 cameras, what is that going to do? That's going to decrease by about $31,000. So that's what that means. Okay. All right, so let's look at this approximation by increments. Okay, so with marginal cost, marginal profit, marginal revenue, what was that? That was increasing by 1 unit. Okay, by 1 unit. So now let's look at this. If f of x is differentiable at x equal x naught and delta x is a small change in x, then f of x naught plus delta x is equal to f of x naught plus f prime x naught times delta x. Or you could say if delta f is equal to f of x naught plus delta x minus f of x naught, then delta x is equal to f prime of x naught times delta x. So basically what we're doing is we're taking the derivative of the function and multiplying it by the increment, by how much we want to increase it. So let's look at an example. All right. So it says, suppose the total cost in dollars of manufacturing Q units of a certain commodity is C of Q is equal to 3Q squared plus 5Q plus 10. This is the word if. If the current level of production is 40 units, estimate how the total cost will change if 40.5 units are produced. So remember, in the previous problems that we worked with marginal cost, revenue, and profit, it was wanting to know from like 40 to 41 units, a 1 unit increase. But this, we're only increasing by half a unit. Okay, so we've got C of Q is equal to 3Q squared plus 5Q plus 10. Okay. Now, remember, delta C is this. That's equal to C prime of x times delta x. I'm sorry. CQ of x times delta q. It's the change in q. Our function's in terms of q, not x. So we have delta c is equal to 6q plus 5 times delta q. And in this case, what are we looking for? Well, q is equal to what? 40, because we want to know from 40 to 40.5. You see that? So remember, when we went from 8 to 9, what did we evaluate at? 40. Q was 40. Now, what's the change? What is the change? Well, the change, the delta Q, is the 40.5 minus 40, which is 0.5. So this is your delta Q, which is 0.5. That's the increment that we're going up, a half a unit. And so we get delta C is 6 times 40 plus 5 times 0.5. And that is going to give you $122.50. Okay. All right. So that's how we approximate just increasing by not a whole unit. Okay. It's the same thing. It's exactly what we did before. We're taking the derivative of the function and then evaluating. Look at this. We're taking the derivative of the function just like we did before. See, there's your derivative. I wanted to do that in a different color. So we're taking the derivative of the function. You see that? And we're evaluating the function at this value here. But the only difference is we're multiplying by our increase. And you say earlier, well, we didn't multiply by anything earlier. Well, think about it like this. When you did when we did this marginal revenue here, I mean, think about it. What if you multiplied this by the increase in the unit? We went from 8 to 9, so what was the increase? 1. And then, if you multiply 1 times anything, you get the same thing back. So if that helps you remember it, look at it that way. Okay? So, but it's really exactly like what we were just doing. You're just multiplying by the increase, that 0.5. All right. So let's look at this problem. It says, during a medical procedure, the size of a roughly spherical tumor is estimated by measuring its diameter and using the formula V equals 4/3 pi r cubed to compute its volume. If the diameter is measured as 2.5 centimeters with a maximum error of 2%, how accurate is the volume measured? Okay. I left out the word is. How accurate is the volume measured? All right, so a few things we've got to do here. So one thing we realize is that it says, where is it? It says it somewhere. Procedure is estimated by measuring its diameter. Okay, by measuring its diameter. So X is we can let X represent the diameter, which is 2 times the radius, right? And so we get that the radius is equal to X over 2. So for our volume is 4/3 pi r cubed, or we can say our volume is 4/3 pi times the radius squared, right? Times the radius, the radius cubed, which is X over 2 cubed. And so the volume, well, this X over 2 cubed, let's write everything out. I was going to take a shortcut, but I won't. And so now we get our volume is equal to, that's going to be what? 1/6. Whoop, I'm sorry. That X squared should be X cubed pi X cubed. So there's your volume. So we have our formula now. All right. So the volume, okay, so we want to use X equals 2.5 centimeters, right? That's what we're looking for. Now, what does it tell us? It tells us that there's going to be a maximum error of 2%. Okay? 2.5 with a maximum error of 2%. So that 2%, that's the error in measuring what? The diameter. You see that? The diameter. So the error, what would be our error? Our delta x. That would be 2.5 times 0.02, right? 2%. And so that is going to be 0.05. And it could be plus or minus, couldn't it? Well, let's do it this way. Let's write it this way so you don't get confused. This is 0.05. Okay, that's our error. So delta x could be plus or minus 0.05 because it could be 0.05 centimeters larger or smaller. Okay. So what do they want to know? They want to know the maximum error in volume. So this is where we take delta V is equal to, what is that? 1/2 pi x squared times delta x. And there you have it. Now all we do is just plug all these numbers in. We plug this value in, and then we plug in the 2.5. And so delta V is equal to 1/2 pi times 2.5 squared times, and then we got plus or minus 0.05. And so delta V is equal to, when you plug all of that in, you get plus or minus 0.491. And that's going to be cubic centimeters. All right. So the actual volume is going to be, well, first I guess we need to get the volume. Let's get the actual volume of this thing, which is, volume is 1/6 pi x cubed, which is 2.5 cubed, and that's going to be 8.181 cubic centimeters. And so if we subtract this number from this number and add it to this number, then we're going to get, well, let's just write it out. 0.181 minus 0.491 is less than or equal to 8.181 plus 0.491. And so that's going to be 7.69 less than or equal to V, less the volume, V is the volume, 8.672. So we can expect it, the tumor must satisfy this right here. It'll be between those two numbers. All right. But this right here is your actual error in volume. So so let me just summarize what we did. So we have a tumor and we measure it. We measure the diameter. How accurate are you going to be at measuring a circle, the diameter of it? Okay, a little bit of it's eyeballing it, stuff like that. Are you getting it on the widest part and all that good stuff? So we measure it to be 2.5 centimeters, but we're saying, we may be off by this many centimeters, which is 2% of 2.5. So if we're off by this much, and either way, 0.05 too much or 0.05 too little that we measured. Okay, so let's say our measurement's off. How off is the volume going to be? Well, the volume's going to be off by that amount. Okay, and it's a, so we would get a measurement between one of those, between these values here. Okay, I hope that made sense. All right, so let's look at this one. It says the daily output at a certain factory is Q of L is equal to 900 L to the 1/3 units. Let's just go ahead and I don't open up all that stuff. So we got Q of L is equal to 900 L to the 1/3, where L denotes the size of the labor force measured in worker hours. Currently, 1,000 worker hours of labor are used each day. Use calculus to establish the number of additional worker hours of labor that will be needed to increase daily output by 15 units. All right, so let's just see what we have. So we have our function here, and what all does this tell us here? Well, we've got L is equal to 1,000. And then what does this mean right here? Use calculus to estimate the number of additional worker hours of labor that will be needed to increase daily output by 15 units. So we want to change it by 15 units. Okay, so what is that? Well, Q of L units. And so delta Q is equal to 15. That's the change in units. So what we need is delta Q is equal to 300 L. The 1/3 comes down, subtract 1 from the exponent. So that's to the negative 2/3. So let's write delta Q is equal to 300 over L to the positive 2/3. Remember, if you have something and you move it across the fraction bar, it changes the sign of the exponent. All right. So let's see, of additional worker hours of labor, use calculus to estimate the number of additional worker hours of labor. Okay, so how much does the number of hours need to change? Additional worker hours. So we're actually looking for delta L. Oh, I'm sorry. I forgot to multiply by delta L. Okay. All right, so that's what we're looking for. So we've actually got, let's come over here, we've got 15 equals 300 over 1,000 to the 2/3 times delta L. All right, so delta Q is 15, L is 1,000, so I plug all that in, and now I've got to solve for delta L. So basically, to do that, what are we going to do? We're going to multiply by 1,000 to the 2/3 over 300, multiply that to both sides. That cancels it out there. And so I'm left with delta L is equal to 15 times 1,000 to the 2/3 over 300. And that's going to be 5 worker hours. That's what you would get if you punched all that into your calculator. Okay, I'll check and make sure, but I think that's right. Yep, I just punched it in my calculator again to make sure, but it is 5 worker hours. So see, the thing is, you've got to understand that, and this is a pretty good example. You've got to understand that delta Q means the change. Delta whatever, that's the change in something. Okay, that's how much it's changing. So you can see they tell us that the units change by 15. So that's why delta Q is 15. And they want to estimate the number of additional worker hours. So how do the hours need to change? That's delta L. Okay, and so then you just plug everything in and solve for whatever you need to solve for. All right. All right, so if you've come this far, just hang on, don't leave, keep watching. We've got just a couple more examples to work. It says the percentage change of a quantity expresses the change in that quantity as a percentage of its size prior to the change. In particular, percentage change equals 100 times the change in quantity divided by the size of the quantity. Okay, that makes sense. How much does the quantity change divided by the size of the quantity? So an approximation formula for percentage change. So here's our formula we'll use. If delta x is a small change in x, the corresponding percentage change in the function f of x is percentage change in f is equal to 100. The 100 just converts it from a decimal to a percent. Delta f over f of x. And what is delta f? Well, that's f prime of x times delta x. Okay. Remember the delta, way back up here at the beginning of the video, we showed, there it is. See this right here. Okay. Whoop. There we go. Whoop. And so this is your formula that you're going to use for your percentage change. So let's look at an example for that. It says the GDP of a certain country was N of T. So let's just go ahead and write that down. N of T is equal to T squared plus 5T plus $200 billion T years after 1997. Use calculus to estimate the percentage change in GDP during the first quarter of 2005. All right. So how do we do that? All right. So the percentage change, so in this problem, the percentage change is going to be 100 times n prime of t times delta t over n of t. So I need the derivative. So n prime of t is 2t plus 5. There's my derivative. And now I need to know, what do I need to plug in for t? What do I plug in for t? Well, from 1997 to 2005, that's going to be 8 years, right? And then delta t, now notice, so we've got from 1997 to 2005, that's 8 years. And then, so that would give us for the 8 years, but it's the first quarter, right? During the first quarter of 2005. So delta t, we would have an additional 0.25. Okay. So now we get, well, let's just go ahead and, well, no, let's do it this way. Percentage change, is equal to 100 times n prime of 8 times 0.25 over n of 8, right? And so that's going to be 100 times, all right, n prime of 8, that's going to be 2 times 8 plus 5 times 0.25 over, and then n of 8 is 8 squared plus 5 times 8 plus 200. We plug the 8 into there for the n of 8. And that ends up giving us 1.73%. Okay, so it's just 1.73%. All right, and we're talking about billions of dollars, right? So whenever you see a change in something of billions of dollars, you think, oh gosh, that's a lot. But you got to look at it for the total and see it's just 1.73%. All right, so let's look at this. Differentials. That's basically what we've been doing here is differentials. So the differential of x is d of x equals delta x. And if y equals f of x is a differentiable function of x, then dy is equal to f prime of x dx is the differential of y. So for the differential, it's what we've been doing up here. The differential is just the derivative of the function times that dx. See, dx is equal to delta x. So here we go. So if we want to find the differential, we've got dy is equal to, so it's just the derivative of this, which is 3x squared minus 14x times dx. And that's it. That's some tough stuff there, isn't it? All right, let's look at this one. dy is equal to, now watch this one. This right here, we're going to use what? We're going to use product rule. So the product rule, this is my first function, this is my second function. So it's the derivative of the first function times the second function plus the derivative of the second function, which is negative, not negative x, negative 1 minus 4x times x squared plus 5. Okay? And so now we need to multiply, and then this would be times dx. Now, I mean, you might see some people just leave it like that, but we'll multiply it all out. So dy that's going to be 6x minus 2x squared minus 4x cubed plus, and then that's going to be plus negative x squared minus 5 minus 4x cubed minus 20x dx. And so now we just combine like terms. Let's see, hopefully I don't screw up, make a mistake here. Let's see, that's going to be what, negative 8x cubed. You understand how to take the derivative. If I miss this, get this wrong, I just made a stupid mistake. Now let's see, those are gone. Let's mark these things out as we do them. And so that's going to be minus 3x squared. That one and that one. And then I've got 6x minus 20x is minus 14x. So those are gone. And then it looks like I got minus 5. And then all of that times dx. And there's your answer. All right. There's the answer to that one. All right. So not too long of a video, but informative and interesting, right? Hopefully it didn't put you to sleep. All right, so I hope you enjoyed this video. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.